Dear students, welcome back to Chem Aspire. This is part 3 polymer lecture series. In this video, we are going to discuss about stereospecificity or tacticity of polymers. So let us know what is meant by stereospecificity or tacticity of polymers. The orientation of the monomeric units in a polymer chain may take place either in an orderly fashion or disorderly fashion. That means what? When the monomers combine together to form a polymer, the monomers can orient themselves in an orderly fashion or disorderly fashion. So this is called as stereospecificity or tacticity. The orientation of the monomeric units in a polymer chain, may take place either in an orderly fashion or disorderly fashion. So depending upon the orientation of the monomeric units, the polymers are classified into isotactic polymer, number 2, syndiotactic polymer, number 3, atactic polymer. So let us define each of these in this class. So first let us know what is meant by isotactic polymer. Iso means same. So what is this isotactic polymer? If the functional groups of the monomeric unit lie on the same side of the polymer chain, we get a isotactic polymer. Let me repeat once again. If the functional groups of the monomeric unit lie on the same side of the polymer chain, we get isotactic polymer. All the functional groups will be lying on the same side of the polymer chain, and this arrangement, same side of the polymer chain, is a cis arrangement. When the groups are on the same side, we call it as a cis arrangement. So let us explain this isotactic polymer taking a simple example. So we'll see the example for isotactic polymer. Let us take the example of isotactic polystyrene. So we'll take the example of polystyrene, CH2 double bond CH, C6H5. So this is your styrene molecule. So say n number of styrene molecules are undergoing polymerization to give polystyrene. Okay, so what is the structure of polystyrene? CH. So the chain goes like this. Okay, so this is the polystyrene molecule, Here, this is isotactic polystyrene. You see here, styrene undergoes polymerization to give polystyrene. Here the functional groups lie on the same side of the polymer chain. Right? This arrangement we call it as a cis arrangement, and this is what is called as the isotactic polymer. This is called as the isotactic polymer. Now we know what is isotactic polymer. If the functional groups of the monomeric unit lie on the same side of the polymer chain, we get isotactic polymer, or the polymer is known as isotactic polymer. We have explained this with a simple example of styrene to get isotactic polystyrene, where the phenyl groups lie on the same side of the polymer chain. Now, the second type of polymer is syndiotactic polymer. So, what is meant by syndiotactic polymer? If the functional groups of the monomeric unit lie in an alternating fashion, let me repeat once again, if the functional groups of the monomeric unit lie in an alternating fashion, or it is lying in the trans arrangement, we get syndiotactic polymer. If they are arranging in an alternate fashion, or if it is in the trans arrangement, we get syndiotactic polymer. The same example we can take and we will see how a syndiotactic polymer will look like, right? So, we say that it is in the alternate arrangement, alternate fashion. Okay, alternate fashion. So, how the syndiotactic polymer will look like? See here, this is your syndiotactic polystyrene. So, this is in the trans arrangement. You see here, so styrene undergoes polymerization. When you are getting syndiotactic polymer, you can see that the groups are in the alternating fashion, one down, one up, one down, one up, like that. It is a trans arrangement. So, that type of polymer is called as the syndiotactic polymer. So, what is syndiotactic polymer? When the functional groups of the monomeric unit lie in the alternating fashion or in a trans arrangement, we get a syndiotactic polymer. So, let us know what is meant by atactic polymer. The third one is called as the atactic polymer. So, what is atactic polymer? If the functional groups of the monomeric units are arranged at random, right, there is no regular arrangement. It is neither in the cis arrangement or the trans arrangement. Some groups may be down, the third group, two groups may be down, third group may be up, fourth group may be up, or it can be down. So, if the groups are lying at random, we call it as a atactic polymer. The same example we can see, you take this styrene molecule and let us know how a atactic polystyrene will look like. We will see how it is going to look like, right? So, how the thing will look like, right? It can be in any arrangement. Right, so one down, one group down, another group up, third group again up, another group down. It can be in any arrangement, one up, one down, something like that. At random, if it is arranged, we call it as a atactic polymer. So, atactic polymer, here the functional groups are arranged at random, we get a atactic polymer. The example is polystyrene, atactic polystyrene. So, in this class, we have discussed about the tacticity or stereospecificity. It is nothing but the orientation of the monomers may be in an orderly fashion or disorderly fashion. Depending upon it, it is arranged as syndiotactic, atactic and isotactic, and we have also seen examples taking styrene as an example. Thank you so much. We'll see in the next class.